Okay, so we come to natural rubber. All right. Has anybody ever tapped a rubber tree before? Anyone here? You know, as you know, Malaysia is one of the largest producers of natural rubber. Susu getah, they call it. Anybody has ever tapped a rubber tree before? Satish, have you done it before, Satish? Anyone?
No.
Because most of us are all, even I've never done it before. All right. But what I did was actually, because I'm from town, unless you live in the rural areas, okay, then some people from the estates and all that, okay, or the small holders, pekebun, they call it pekebun kecil, they also grow rubber trees, okay. If you're in the rural area, then you have a chance. I think the last time from Sri Damansara, the nearest rubber trees will be in RRI near Sungai Buloh, that side there. Now they have removed that whole area. The whole area has been converted to housing already. Unless you go further to on Kuala Selangor side, then you can see all the rubber estate. But when I was in the third year in my university, all right, what I did was I took part in a program where I stayed with 1 month during my vacation in an estate, just to know what is life all about. I stayed with my foster family, about 6 of us from the university, okay, and then we just wanted to know how life is there. So I used to uh, accompany my foster, all right, when she goes out to tap rubber, she'll go out around 6 o'clock in the morning, to tap the rubber, and one person will tap roughly about 300 rubber trees in a day. Okay, so it's a good experience. All right. So we come to natural rubber now. So first you look at it, natural rubber, they are natural polymers first. One of the natural polymer is rubber. The rubber or the latex from the rubber tree. Okay. So this one, those who do bio, okay. The first natural rubber, the monomer is the building block. I told you the other day. You take ethene is a monomer, the polymer is polyethylene. Those are plastics. But those are not natural because those are chemicals made in industry. We're talking of something which occurs naturally. So natural rubber is a polymer. Starch is also a natural polymer. It's a large molecule. Polymers are large molecules. Proteins are large molecules. All right. Okay. For chemistry, we don't use the word lipids. We use the word fats. That day we learn. Okay. So the monomers will be fatty acids, glycerol to make fats. For protein, we have amino acids. You join the amino acids and then you get different types of proteins. You take glucose molecules, you join up together, you get starch. Okay. Now, the monomer for rubber, they call it as isoprene. Can you please highlight that one? Isoprene, the monomer for rubber. That means the building block. Okay, so this is something new lah. Okay, this one we did the other day. Remember not? Okay, put a note here. This is ethene. Here, right down below here, ethene. I guide you, write it, please. So, okay, why I'm doing this because it's related. Okay, ethene, E-T-H-E-N-E. Correct, ethene. Okay. Carbon double bond, so the N is in front, then the bracket there. Okay, this one you don't need to know, this is the condition. But I told you, the double bond becomes a single bond. That day we learned, isn't it? All right, and then there's a long line here, one line here, another line here, come out from the bracket, and then the N is there. Is that clear? All right. Okay, so this is polyethylene. Okay, write that down first, below here first. This is your polymer. This is what we learned so far when we did alkene. Polyethylene, E-T-H-E-N-E. Okay? Why I'm doing this? Because I'm linking the rubber now. Okay, so far, okay, ethene, polyethylene. This is polymerization. So we're looking at the process of polymerization. Ready? Okay, padam, Can I continue? Okay, so this one you have to know, in case they ask. Okay, see, you have to know this is how isoprene looks like. Can you see here? Okay, the only thing, it's not an alkene, It looks as, okay, some students said, it looks, although it ends up with the word E-N-E, but it's not an alkene. But it has got how many double bonds? Can you see? I'm going to circle now. Okay, I want you to circle this also. Yeah, I will just use one. Okay, I use this. All right, you see here, I want you to circle one double bond. Circle that first. And this another double bond. All the while, kita belajar alkene. We learn alkene, only one double bond, isn't it? That's all carbon-carbon single bond. Remember? Butene. pentene and all this. But this is very special case. Can you see, There's two double bond. Okay. How you know it's not alkene? Okay, remember alkene? Okay, Jaing, what's the general formula for alkene, Jaing?
CnH2n.
CnH2n, isn't it? Okay, we count and see. So how do you know it's not an alkene? You can see here. Count. 1, 2, 3, 4, 5 carbon. So it's C5. If it's an alkene, it should have 10 hydrogen, isn't it? Okay, let's check first. 1, 2, 2 plus 3 is 5, 3, 4, 5, 6, 7, 8, C5H8. Can you see that? So it's not an alkene. So it's another molecule by itself. So this is what we call as isoprene. Why we use ENE? Because we've got a double bond there. Okay, that's the old name, but you can still accept that. Okay, so I clear. All right. So you see here, okay, one double bond here, all right, and another double bond there. Okay, remember we did here, all right. Double bond becomes single bond, isn't it? So two double bond becomes one double bond here. So you add up and see, you count and see, 1, 2, 3, 4 carbon. So 1, 2, 3, 4, 1, 2, 3, 4. These two you don't cut out, or you don't disturb everything. Only thing the double bond comes in the middle. Understand? So this is called isoprene, which is a monomer. This is natural rubber. So what's another name for natural rubber? You put a note here, polyisoprene. Well, we did this. Ethene, polyethene. So the monomer for rubber is isoprene, the building block. Okay, you want to build a house, you must put bricks, isn't it? The bricks are the building block. Natural rubber is a polymer. It's a natural polymer, okay, coming from the rubber tree. So can you tambah the word there? Polyisoprene, one word. Polyisoprene. Another name for natural rubber, polyisoprene. Okay, so we'll start now, Okay, let's go first one. The monomer for rubber is isoprene. Write that down first. ISOPRENE. Quickly. Monomer for rubber, I'll zoom in a bit, Isoprene, okay. All of you can see, Okay, monomer for rubber is isoprene. Okay, what is the IUPAC name? Okay. Right, so you can see here, you start the numbering from, okay, let's say we start from the left, because the CH3 is closer here to this carbon. So 1, 2, 3, 4. All right, 1, 2, 3, 4. At carbon number 2, there's a methyl. So I put 2-methyl. Write that down first. 2-methyl. I put, okay, small alphabet. 2-methyl. Okay. Correct? I leave a space. There's no comma there. 2-methyl, then bute. Why bute? Because 1, 2, 3, 4. 4 carbon. 1, 2, 3, 4. Can you see? Bute. Is that okay? 2-methyl. Methyl is a carbon number 2. Bute. 1, 3. Because the double bond is between the first and second, so it's 1. The double bond between third and fourth is 3. Can you follow me? Okay. 2-methyl bute, comma, dash, 1, 3. Then this one is, we call it as a diene. Why diene? Because it has got 2 double bond, and it's got, we whenever anything with ENE, we can say it's an alkene, but it's not an alkene. So I call it diene. In case they ask what is the IUPAC name, you have to know. But usually in most cases, you can just say polyisoprene, they accept. Monomer is isoprene. The polymer for rubber is polyisoprene. Monomer is ethene. Polymer is polyethene. Macam itulah. Okay. Okay, have you written this down? Okay, this is your answer. Okay, Okay, we go next page. All right. So let's look at natural rubber. The most famous example is a rubber band. It's soft and elastic. Rubber is soft and elastic. All right. Does not conduct electricity. Is that clear? Does not conduct. Okay. And it is not heat resistant. You take a rubber band, let's say you leave on your table. You take a few rubber bands, you leave on your table. And then let's say you go for a vacation. You go for 2 weeks, you come back after 2 weeks and see the rubber band all become like soft already. And you can just pull it a bit, it will break. Okay, so it is not heat resistant. When its temperature is a bit warmer, slowly it becomes soft, and then you can break easily. So it's not heat resistant. resistant, yeah? Okay. And then easily oxidized by air. Right? So it becomes hard, Okay, sometimes, you take a rubber band, you can see, you leave it, you pull and see the rubber band, which is harder, all right, and a bit rough, you pull it, it breaks easily. Whereas you buy some new rubber band, it's not like that. Okay, easily oxidized by air. Huh? Okay. Right. Now, this is the most important thing. Okay, ready? Yeah? Okay, this is, a latex. Huh? Okay, when I followed my foster mother in the estate last time, okay, I asked her why you're going out so early. Then I realized, she said, you go early. The earlier you go and tap the rubber, all right, the more is your latex that you can collect. You go around 10 o'clock in the morning and you tap the rubber tree, then the latex flow is very little. When the latex flow is very little, then they won't get much. Because the rubber tapper, they will tap about 300 rubber trees. So they will go around about 6 o'clock in the morning. All right? So by the time they reach the rubber plantation there, it will be about 6:15. Okay. So each rubber tapper has got 300 trees to tap. They know the area there. They will just tap. It's not so easy. You must remove the layer of bark. Can you see the guy there? It's not so easy. You see, you just remove one layer of bark here and one layer of bark there. That's it. Then you go to the next rubber tree. Can you see that? All right. And then the latex will flow, into a cup. And then it's not immediate, so they will tap the 300 rubber trees and then they'll go back home. So by the time they go back home, it'll be around about 9 o'clock. 8:30 to 9, all right? Okay, and then in the morning, and then they'll go back, do their cooking, whatever. So around 12 o'clock, all right? Roughly around 12 o'clock, they go back. Because by that, at 12 o'clock, the cup will be full. Because the flow is very slow. Understand? But you tap very early in the morning, the low temperature, it will stimulate more latex to flow. You go and tap in the afternoon and see the flow of latex is very slow. Because the higher temperature in the afternoon will affect the flow. Okay, yeah? Right. So you can see this is the latex. It's quite thick, Right? We have it in the school lab, in a bottle. All right? Okay. You come back, I'll show you. Latex, the mixture of water and rubber particle. Please highlight that one. Mixture of water and rubber particles. Okay, there's water. Okay, so you can see here, this is latex. Each circle there is one rubber particle. Can you see one circle like that? It's a rubber particle. So we go into detail. There are millions of these rubber particles in the latex. One circle like that is one rubber particle. There are millions of this. So you can see here, each rubber particle has got a negative charge. Can you see that? Negative charge. That's the first thing you must know. And then there's a membrane. There's a membrane which is made from protein. And inside the rubber particle, there's rubber molecules. See, one circle is a rubber particle. Negative charge. Protein membrane. Okay, and inside you can see the rubber molecules. One molecule of rubber. Okay, the rubber molecules are all joined up together, like a polymer. When I say rubber molecule, you see this one here? This is one molecule, this is another molecule, all will join up. So you can see the word N down there. Can you see that? This one molecule. The same identical molecule will join up and form a polymer. So this is your rubber molecule. Can you see that? Long chain rubber molecule. One long chain rubber molecule. Okay, get it, All right. All right. So let's answer some questions first. Number 2, The rubber particle is made up of rubber what? Okay, rubber what? The rubber particle is made up of rubber molecules. Write that down first. Okay, this is considered rubber molecules that are covered by a protein membrane. Tambah the word protein membrane. Each one circle inside it, there is rubber molecules. These rubber molecules surrounded by a protein membrane. What charges? Negative charges. Okay, that's the first thing you must know. Okay, so one rubber particle is negative, other rubber particle. So negative will tolak, I know. Betul? We learn in physics, isn't it? So the two rubber particles will not come close together. That is why you find that when you tap the rubber tree, the latex remains in liquid form. Because the rubber particles are all negatively charged, so they repel each other. So number 2 now, under normal circumstances, particles will repel, R-E-P-E-L, menolak one another. Because they have the same negative. So negative will tolak. Okay. So the repelling force between the rubber particles will get very close to one another. Because they get very close, they can the membrane, they will collide, the membrane will break. So this negative charge keeps the rubber particles in liquid form. So the latex remains in liquid form when it flows up the rubber tree, because the negative will the charges, the protein negative charges in the protein membrane. Okay, you have to know this, huh? Okay, we continue. Right. So now I go to the next part, coagulation of latex. Okay. See, in a rubber estate, where after the rubber tapper, all right, has collected the latex. So I followed, no, when my mother went, foster mother, when she went to collect the latex, I just followed her. Okay. Each rubber tapper is given one pail, they have to fill up the whole pail, Okay. So the whole pail is filled with latex. Of course, those days, what some rubber tappers used to do, they'll collect a bit of latex, they add water to fill up the pail, It still looks white, isn't it? But of course, in the factory, they can check. They will take a special hydrometer they put inside the latex. If the latex is filled with water, the reading is different. If it's pure latex, the reading is different. So no rubber tapper will do that. You understand or not? They'll collect pure latex. One pail like that. Okay, All right. So they will take it to the factory, and then what they'll do is, this is what they'll do, Okay, I just show you first. This picture here. See this picture here? They'll pour the latex into like a tong, and it's like trays, they'll pour into trays, Okay. And then they'll add an acid, The acid is a weak acid, you have learned, methanoic acid, but they call it formic acid. All right, after I'll show you, They'll add the acid there, and then they leave it for about 1 hour in the factory. This one is not the work of rubber tapper, the factory, the workers, the other part of the factory. Okay. And then after 1 hour, the latex will harden. Understand? Okay. And then they'll take the latex, you see like this, can you see? Like a slab like that, all right? They'll put it into a roller like the taboo, sugarcane for sugarcane juice. And then they'll remove all the water. They'll do a few times, they'll roll, Okay, they remove the water, all right? And then they take the latex and then they dry it. And they dry, the latex becomes brown in color. That's all. And then they sell it. The rubber factory, of course, rubber factories are all owned by big companies. They will sell it. And the price of rubber follows the international rubber price, just like petroleum and oil palm. We have a standard international price. It changes day by day. It can even change by week and so on. Okay. All right. These are market forces. Okay. That's how okay. So we are going to come to that now. How to harden the latex. Because I told you, all right, when the latex is hardened, then they'll sell the latex to tire factory. They'll sell the latex to other factories which use rubber products. Is that clear? All right, to make gloves or whatever. Okay, So note it down first. Acid such as formic acid. Formic acid, that's an old name, but now they call it as methanoic acid. HCOOH. Okay, highlight that one first. The acid is formic acid or methanoic acid. It's added to the latex. That is done in the factory, Okay, put down first. Okay, if it's acid, put down hydrogen ion, put H plus here. Hydrogen ion that has a positive charge, no doubt, H plus is positive charge, will neutralize the negative charge on the protein membrane. The protein membrane, there is a negative charge here. So when I add H plus, okay, so you see that's what happened. Latex before acid is added. Can you see that? This is a negative charge here, right? So when I add the H plus will neutralize all the negative. All the negative will be neutralized. Okay, so this becomes neutral now. This rubber particle becomes neutral. All the positive from the acid, positive ion from the acid, the hydrogen ion will neutralize the negative. So now once this rubber particle is neutral, they will collide with each other. So when they collide, the membrane breaks and then the rubber molecules inside will all combine together like one lump, and so the latex has coagulated or hardened. That's how we explain. That's why we add acid. Of course, the process takes about an hour like that if you have a lot of latex. You understand? It's not immediate. Another question students use, why must we add weak acid? Why can't I add sulfuric acid? Can. Then the process of hardening will be faster, latex, but it will affect the texture of the rubber. So that's why we add weak acid. They don't add strong acid because the texture, the rubber will be different. It will not be soft anymore. Is that clear? Huh? All right. So note down first. Number A done already. Rubber particle are now neutral. Remember I told you just now, we add the acid from the H plus on the acid will neutralize the negative charge. So the rubber particle is now neutral, no charge. So they can now what? Collide, C-O-L-L, okay, melanggar with each other. So when they melanggar, they will cause a protein membrane to break. So when the protein membrane breaks here, can you see this protein membrane breaks? Thus releasing the rubber molecules. So all these rubber molecules inside will come out. Okay. So the rubber molecules will now combine with one another and the latex coagulate. So coagulate means the latex will harden. Please note it down. Coagulate means harden. That's a term we use. Okay. That's one thing. All right. Then, okay, let's say now, I'll give one more. They asked once in exam. Okay, let's say the rubber tapper taps the rubber tree, isn't it? Morning, All right, one rubber tree lah. Okay, contoh, okay, few rubber tree. And let's say he or she goes back home. Okay. And then he's supposed to come around 12 o'clock lah, isn't it, to collect. Let's say 12 o'clock, halfway on the way, let's say, do you know the estate, it's all like, jungle and all that, All right. He or rubber tapper, he or she is bitten by a snake, contoh. Okay, rubber estate, the snakes and all that, or attacked by some wild animal. Okay, so what happens is the rubber tapper will not tap the rubber tree. The latex is flowing, isn't it? So what will happen is after about 1 o'clock, okay, the latex is completely filled already. All right. About 5 or 6 in the evening, the latex will slowly start to harden by itself. How come? There's no acid there. You take a rubber factory, the latex will harden, but this one, it will slowly harden by itself. Why? Because, okay, so that one they can ask you, why does latex harden naturally by itself after some time? You pour acid, it will harden, okay, within 1 hour. You don't pour acid, it will become solid. Why? Because there is bacteria. Bacteria from the atmosphere will enter into the latex. So what the bacteria does, the bacteria will release acid. Understand? Lactic acid, you studied bio, Okay, bacteria releases the lactic acid. But bacteria is very, very small. So the lactic acid release is very little. So slowly, by 5 o'clock, the more and more acid is produced, and then the latex will start to harden by itself. So it's using the same concept. So you can see here, you see, you add acid or even bacteria acts on the latex to produce this acid. Oh, this acid contains hydrogen ion. Understand? So if you take the factory and pour the methanoic acid, the process of coagulation is faster within 1 hour. If no acid is poured, it will harden by itself, but much more slower because of the acid produced by the bacteria. So they will ask you this. Okay, settle with this, So this one you can answer, Okay, we will settle this first, then we'll answer the question. Any questions so far? We talk about the rubber particles, how it looks like, okay? And then we talk about adding acid or even acid produced by bacteria to coagulate. Coagulate maksudnya change the latex from liquid form to solid form. Okay? Then we have another case. Let's say I don't want the latex to harden. I want the latex to remain in liquid form. Okay, sometimes you can see, like a tanker, not a very big tanker, not like the Petronas oil tanker, that one different. Smaller one. I've seen the word liquid latex. They put the word there. Why they want to keep the latex liquid form? Because, now there are many factories in Malaysia which produce gloves. You know, remember? Okay, the one of the top companies is Top Glove. You know, they produce gloves now, especially with the COVID-19. Many countries wanted gloves for the medical staff and all that. You know, in fact, there's a shortage. Okay, so we produce gloves, or sometimes we need to produce condoms. Or okay, you understand or not? All right. So the liquid latex is then sent to the glove factories or even to the condom factory. Okay, can you see that? All right. Okay. So how to keep the latex in liquid form so that it doesn't harden? So what they do, you want to prevent the coagulation means you add an alkali. When you come to school lab, when you come back to school, we have the latex in the lab, I'll show you. And when I add acid, now what happens? You can see it becoming hard very fast. You add ammonia, aqueous ammonia, the latex remains in as liquid form in the beaker. Okay, so what we do is we prevent coagulation by adding an alkali. Again, you cannot add a strong alkali, we add a weak alkali called ammonia solution or aqueous ammonia. Okay, must be a weak alkali. Is that clear? All right. So how to coagulation, note it down, coagulation latex prevented by adding ammonia. That means you want it to remain in liquid form. Okay, so let's explain this one. Ammonia solution contains OH minus, the name, hydroxide ion, write it down. Ammonia solution contains hydroxide ion. So the color hydroxide ions, OH minus means put the word negative charge. So what does the hydroxide ions do? The negative charge, all right, will neutralize any, put the word neutralize, N-E-U-T-R-A-L-I-S, any acid that is produced by the bacteria. Bacteria produces hydrogen ion. So when the OH is there, it will neutralize all the hydrogen ions produced by the bacteria. The bacteria is found in the air. It will enter into the latex. Okay, so there is no H plus, all right? Okay, so no H plus to neutralize the negative charge, so the negative charge will remain. Can you see that? The OH minus here will neutralize any of the H plus produced by the bacteria. H plus means acid. Okay, so the rubber particle will remain with a negative charge. Can you see? There's a negative charge, negative charge. So negative will repel. So the latex remains in liquid form. Okay, so you can see here, hydroxide ions will neutralize any acid or H plus produced by the bacteria. So the negative charges on the protein membrane is maintained. All right, and negative will repel each other. So the latex coagulation does not take place. So no hardening of latex. That's why when you add aqueous ammonia, the latex remains liquid. So they take the liquid latex and then they will send it to the rubber factories. To the factories which make all these gloves. Can you see that? Okay. And whichever factory that makes the gloves, they buy the liquid latex and then they use the mold, you know, the shape of a hand. Or if it's a condom, the mold will be in the shape of a tickler. You understand or not? All right? Okay, you understand, huh? All right? That's all you have to know. Okay? How to keep latex in liquid form or how to make the latex harden. To make it harden, we add an acid. Example is a weak acid like methanoic acid. Okay, the whole name is formic acid. If you want to latex, you want the latex to remain in liquid form, then we add aqueous ammonia. Okay, weak alkali. You cannot add sodium hydroxide. Again, the texture of the latex or the rubber will be different. Huh? Okay, settle with that. Now, one last part. Vulcanization. You see the word vulcanization, huh? Okay. All right. Let's say we have an example. If you have car tires, All right. Okay. Now, if the car tire is made of pure rubber, okay, let's say you make a car tire of pure rubber, okay, you fit it into the car, okay, and then let's say the person drives a car from KL to Johor. And if you go along the road, there's a lot of friction between the tire and the road. So the tire gets hot. Correct? Friction one. When the tire gets hot, then if it's pure rubber, means the rubber will turn after when you say you stop the journey in Johor there, the tire will start to become soft. There goes your tire. One tire costs about how much? About almost 200 ringgit now, present market price. Understand or not? So it's wasting. So what they do is they have this process called vulcanization. This process was introduced by, you see the word Charles Goodyear, because have you heard of Goodyear tires? It's named after him. Yeah? What is vulcanization? They take the natural rubber and they process it so that it becomes harder and stronger and more elastic. So you see, well, highlight this one. Natural rubber needs to be processed by the vulcanization process. Make sure you know how to spell vulcanization. To make it tougher, harder, or tougher or stronger, so can, more elastic and more heat resistant. So you can drive to Johor also, no problem. From KL to Johor, the tire will still remain the same shape. The tire only wears out after 1.5 years like that. Okay. Wear and tear. So the process is vulcanization. So what is vulcanization? Note it down. It's a process where sulfur, write down first, SULPHUR, is added to natural rubber. This one they do it in the rubber factories. Again, in the tire factory they do it. The tire factory buys the natural rubber and then they will melt the rubber and then they add the sulfur. Okay, and so it becomes a tire which is hard, which is strong, which is more elastic, more heat resistant, more resistant to oxidation. It will not be oxidized easily. Can you follow me? This is what we call vulcanized rubber. Okay, yeah? All right. So compared to natural rubber, vulcanized rubber is stronger. Please highlight this one. You'll always ask this. Stronger, okay, more tough, or harder, so can, tougher or harder, more heat resistant, more elastic. And it will not be oxidized easily. Make sure you know this, Okay. How you do it, you take the rubber, and this one you don't have to do, but you just have to add this thing called sulfur monochloride mixed with methyl benzene. But that means we are actually adding sulfur to the natural rubber. Okay, or another way is to heat the natural rubber with sulfur. In factories, they do the first method, but you can do this. Okay, you add sulfur. Okay, so when the rubber is made by the vulcanization process, this rubber is known as vulcanized rubber. Please highlight that. Vulcanized rubber. Now you see the word vulcanized, it's different from natural rubber. Natural rubber, we don't add any sulfur. Okay, like normal rubber bands on, okay, we don't add sulfur. Because you want to do the process is more expensive, you know. Rubber band, we don't know. We're just going to tie up a piece of, like a bundle. After that, we throw the rubber band. So why you want to do vulcanized rubber? No need, wasting. Understand? Like condoms and all that. Condoms and gloves and all that, then they are not vulcanized. Because expensive. Condoms you use once and then you throw. Nobody recycles condoms. Correct? Medical gloves you use once and then you throw. The doctors will throw. Understand? We don't recycle because the bacteria, all that. So why you want to do vulcanization? Vulcanization is like rubber hose outside your garden there. Can you see that? It's exposed to the sun. The soles of your shoes. Understand? You leave your shoes out, your rubber shoes, you leave it outside, the soles are exposed to the sun. So that one is vulcanized. Tire is vulcanized. You understand? All right? Okay. So this is your rubber molecule, natural rubber. You see, so label this diagram here, put down rubber molecule, write down. See the double bond there, can you see that? Just now I showed you, isn't it? The polyisoprene. So put down rubber molecule. Okay, label here. This one, label, rubber molecule. So one rubber molecule, another rubber molecule, so many rubber molecules. So this is your polymer of rubber. This one very important. In the vulcanization process, what the sulfur does, the sulfur atoms will come and attach here. Can you see? Between one rubber molecule and another rubber molecule, there will be a sulfur atom. They call it the sulfur atoms will cross-link. Cross-link means lying in between the rubber molecule. The blue one is a rubber molecule. Okay, you label it now first. I want to label it. Okay, I use my drawing tool. Okay, this one here, put down rubber molecule. This one also rubber molecule. So one layer of rubber molecule, another layer of rubber molecule. Okay, this one is your cross-link. Can you see the word? Can you label that? Circle this cross-link. Okay, so why is it more elastic? You see, okay, let's say I apply a force. Okay, I'm going to remove this first, something like alloy. Okay, let's say you see this one here. Wait, let me just circle this also. Okay, this is another cross link. There is another cross link, and this is another cross link. Okay, let's try to see what we learn about alloy. Okay, I'm going to use an arrow here. Okay, so let's say I apply a force. When I stretch the rubber, okay, I'm going to apply a force. So when you apply a force, all right, okay, let's say, right, this layer here, all right, I'm going to use like a drawing tool, or I put like this. This layer will slide like that here. This layer will come here now. All right, wait, let me do it again. I'll do it again. Let me see, wait. Okay, my drawing, okay, when I apply a force here, all right, sorry, I do it again. I apply a force, correct? Apply a force here. You see this layer here, the blue layer, the blue layer will move now, it'll go like this. The blue layer will go like that. Can you see that? But you see what happened? These sulfur atoms are attached here, Can you see? So what happened? The sulfur atom will slowly pull back this to the normal shape. Understand? This one is remaining stationary. This blue layer will now move to this area. But you see the sulfur atoms are here. Wait. Let me erase that. I erase the sulfur atom. Now I put this one. And you see the sulfur atoms are in the form like a line here. Can you see that? Sulfur atoms are here. So slowly they'll pull it back. They'll stretch it and bring it back to the normal position. So that's why vulcanized rubber is more elastic. Can you follow the picture? All right, it's very clear. Because of the highlight the word sulfur atom will cross link. They'll form like a cross link with the rubber polymer. Rubber polymer means rubber molecule. So that's all you have to know. Okay, all right. Quite clear. All right, then we go next page. So when you do vulcanization, because of cross link, okay, so highlight this one. This will decrease the ability of the rubber, the molecules to slide. You won't slide much. You move a bit also, the sulfur atoms will pull it back. Okay, that's why vulcanized rubber is harder, stronger, and more elastic, more difficult to stretch. Elastic means when you stretch it, it comes back to its original length. We remove the force. Please note it down. So where can we use vulcanized rubber? Okay, we use it for vehicle tires, car tires, motorcycle tires, and all the tires for vehicles, aeroplane tires also. The soles of the shoes, yes, because it's exposed to the sun outside when you leave your rubber shoe outside the house. For gloves, I'm not talking of the surgical gloves. Sometimes you see the garden gloves, you see, like red, it's like pink in color sometimes. So that your hands will not come in contact with the thorns from the plants and all that. That's garden gloves. That one, black in color, or sometimes pink in color. That is the glove I'm talking. Surgical gloves, no need, because we're going to throw the surgical glove. Garden gloves, we reuse it. Then electrical insulation for wires, and also all the rubber hose. So these are all the items made from vulcanized. Mainly for tires. Okay. So this one they'll ask like that. Okay, so this is a comparison. Okay. Latex, you add. Okay, somebody's asking me something. Let me see first. Okay. Yes. What's the question? No question. Okay. Yes, Ming Chun, what is it? What's your question? Can you put a question there?
Press wrong.
I cannot see. There's no chat.
I pressed wrong.
Okay, never mind. So any questions so far? Okay, so latex, you coagulate, all right, is unvulcanized. All right. When you add sulfur, becomes vulcanized. This is a rubber factory, okay? This one you send to the tire factory. They produce a vulcanized rubber. How to do vulcanization? You add the sulfur to natural rubber, it will form like a cross link. What acid we add? Formic acid, make sure you know, or methanoic acid, okay? Weak acid. And the normal rubber is softer, less elastic, easily oxidized by heat and all that. This one is stronger, tougher, more elastic. Can you follow me? All right, it's very straightforward. Okay. So they'll always ask you to make a comparison between natural rubber and vulcanized rubber. So this is soft, this is hard. Natural rubber is less elastic. This one they always ask an exam. Vulcanized rubber, you can stretch, it'll come back to natural length. Okay. This one is not heat resistant. After some time, it becomes soft. This one is, you can stand the heat, withstand the friction and all that. So it doesn't change shape and all that. Okay, low melting point. This one is high melting point. And this one is very easily oxidized. This one is more difficult to be oxidized. So you must know the characteristics. Okay, so that's it. So now we start with our revision questions for this chapter. Are you ready? Yeah? Okay. So let's look at the structure of rubber. Rubber is natural polymer. It is formed from the monomer called, put the word isoprene, I-S-O-P-R-E-N. You don't need to know the IUPAC name, just put isoprene. Okay, molecular formula study, we calculated C5H8. Write that down first. It's not an alkene. Kalau alkene be C5H10. This is C5H8. So number C, isoprene molecules are joined together by the polymerization process to form the polymer of natural rubber called, put the word polyisoprene. One word, poly, then isoprene, which is called natural rubber. Okay, so now we go for latex. Coagulation means hardening of latex. Latex is a milk-like liquid from the rubber tree. You must tap it. You don't tap, nothing happens. You remove a layer of bark from the tree. Okay, latex contains a suspension of rubber particles in water. Rubber particles in water is latex, so it's liquid form. Okay, the rubber particle is, the word particle is negatively charged. I told you that the protein membrane has a negative charge. So one rubber particle, another rubber particle, a few particles, they cannot collide because negative will repel. So the forces of repulsion between the negatively charged particles, negatively charged particles, prevent them from combining. They come and collide and then they coagulate, So there's no coagulation. Okay. This one is latex coagulating naturally. I told you, isn't it? The rubber tapper doesn't collect the rubber from the cup after a few hours, and if you don't collect it at all, then it will harden by itself. It is left aside for 1-2 days. So due to bacterial action on the latex, bacteria produces lactic acid. Note that. That contains what? Hydrogen ions. So the latex will slowly coagulate. Factory, it coagulates much faster. This is a factory. Can you see that? Okay. This is a liquid latex where they've added and then they leave it in a tray for about a few hours. Is that clear? Okay, when acid is added to latex, coagulation takes place. Betul lah? Yeah. How do you explain? Positively charged hydrogen ion from the acid. Betul, H+. Put a note there, H+ from the acid, the ethanoic acid, methanoic acid will neutralize the negative charges on the protein membrane. So a neutral rubber particle is formed. There's only one rubber particle. There are millions of these neutral rubber particles. So the rubber particles will no longer repel each other. Okay, so they will collide, no? All right? So these neutral particles will now collide with each other. Belanggar, causing the protein membrane to break. So inside the rubber particle, there's rubber molecules. So that there's no there. The rubber molecules are now free to move. And they will, what? Clump, C-L-U-M-P. Clump together, form like a lump. Like a kettle, They will clump together to forge a large lump of rubber solid. So the latex has coagulated. How to prevent coagulation? You add aqueous ammonia, put the word, or ammonia solution. Okay, so ammonia solution means the alkaline solution, A-L-K-L-I-N-E, is weak at alkaline. containing hydroxide ions will neutralize any hydrogen ions produced by the bacteria. So there's no hydrogen ion, so the negative protein particles will, rubber particles will repel each other. So latex remains in liquid form. Okay. And then we go for vulcanization. Vulcanization, natural rubber is what? Elastic. Okay, write that down first. Natural rubber is elastic. When you take a rubber band, you stretch and then you release the force, it comes back to its natural length, isn't it? We have learned that when we studied physics, Hooke's law and all that. Okay. When the natural rubber is overstretched, you take a piece of that, you stretch it, you take a rubber band, you stretch it like that, and then you release it, it becomes longer a bit. You have stretched it beyond its elastic limit, we have learned in physics. When the natural rubber is overstretched, the rubber molecules do not return to their original position. Okay, so we say the rubber has lost its elasticity. Right on. ELASTICITY. It's no more elastic. Because you stretch it beyond the elastic limit. Remember we learned in physics, Right, but how to make it more elastic, more strong? We carry out this process. Natural rubber becomes stronger and more elastic after vulcanization. So now you see why is this process very important, Okay, so this is put down here first. Natural rubber. The diagram on the left. Can you see? This is all your. So this thing here is your rubber molecules. One rubber is a polymer rubber molecule. This is another polymer rubber molecules. Another polymer. You see all the double bond. Carbon double bond. Just now you saw, isn't it? This one. And I said the double bond. And we go back to the first page. I show you. See here. Remember? You see a double bond there? Where is it? Here. You see a double bond there? This is one rubber molecule. So another rubber molecule will join up. Okay, get it? Only one double bond there. Can you see now? So this is your natural rubber. All right. Then after vulcanization, can you see the sulfur here? All right. The sulfur will form like a bridge, Can you see now? Between one layer of rubber molecules, another layer of rubber molecule, there's a bridge there, like a link, cross link they call it. So this is vulcanized rubber. The moment you see sulfur there, you know it's vulcanized. So put on D. The sulfur atoms form cross-link, like a jambatan, between the long rubber molecule. This is a rubber molecule, this is another rubber molecule. There's a link. Cross-link means in between one rubber molecule, another rubber molecule. Okay, this reduces the ability of the rubber polymer to what? To slide over each other. So it's more elastic. It'll slide a bit but the sulfur will slowly pull it back. Come back to this position. Okay, this reduces the ability of the rubber polymer to slide over each other. So the rubber molecule return to their original position after being stretched. And release. After being stretched and released. Tambah the word release. Anything elastic you stretch, you release the force, it comes back to its natural length. Okay, tambah that. Any questions? Very simple, straightforward thing. All right. Okay, so that's it for today. Any questions you want to ask or not today?